Hello everyone. We are going to talk today about the Mayan system of numeration, which also used the place value system that we talked of before. So we discussed the Hindu-Arabic system, which is also a very ancient system, but it is still used today in the modern world. Then we talked about the Babylonian system that preceded the Hindu-Arabic system, but they did not have a numeral to represent 0. The other system that we'll talk about today is the Mayan system of numeration, and that used the place value system, but it used a different base. So we'll talk about that today. We'll get introduced to their numeral system, and we will learn how to convert from the Mayan system to the decimal Hindu-Arabic system and vice versa. All right. So we see over here, these are the entire set of numerals in the Mayan system. We see that they had a symbol to represent 0. However, the 0 wasn't used the way it was used in the Hindu-Arabic system, where 0 was used to represent larger numbers or even used for arithmetic operation. This 0 in the Mayan system was used just as a placeholder, so to speak. All right. So if there was a digit missing at a certain positional level, then they use this symbol to represent it. All right. So there was a 0, and then it went all the way up to 19. So that means there were 20 numerals in their system, and it started from 0 and went all the way to 1 less than 20. All right. And they used a form of base 20. All right. Now, it was a little weird, little different from the way the Babylonians and the Hindus use their base, and I will demonstrate that how it was different. But essentially it was a base 20 system with a little with a slightly different variation. All right. So they had a numeral for 0, which was a placeholder. And another unique thing about the Mayan system was that the digits were written vertically. In the systems we learned so far, the digits were written horizontally. So if we express the value, let's say 315, we wrote the digits horizontally, right? One after the other. In the Mayan system, we will see that they will represent their numbers vertically. So they would write something like 3, 1, and 5, right? That's how they represented their numbers. But they used, of course, their numeration system. All right. Now, so digits were written vertically, and the positional value increased from bottom up. So we'll go through some exercises and explanation on how their system worked and how they used the place value system. Now let's look at their numerations, the numerals here, what symbols they used. The first one, 0, appears to be two concentric ovals over here. And then 1 was expressed as a single dot, 2 with 2 dots, 3 dots, 4 dots. But for 5, they use a horizontal line. And then 6 was represented as a horizontal line with a dot above. So 5 plus 1. All right. A single dot represents 1, and a horizontal bar represents 5. So 5 plus 1, 6. 5 plus 2, 7. Then 1 bar, and then 3 dots represents 8. 5 plus 3, and so on. And then for 10, it's just 2 horizontal bars. So 5 plus 5. And then 15 is 3 bars, and that's how there's a pattern to their system of numerals, as you can see. All right. Now, if we were to convert from the Mayan system to the Hindu-Arabic system, let's come up with an example of a numeral of a number in the Mayan system here. So I'm going to, and let me think of a number here. I'm going to write it like this. So let me pull up the pen. All right, now here we are converting from Mayan to decimal, from Mayan to the decimal system, which is the Hindu-Arabic system, really. All right, so I'll start with the numerals showing like this, and then followed by 3 dots here. And then in the next line, it's 1, 2, 3, and then a dot. Yeah. All right. So this represents a number, this design here. This is 2 bars with a dot above would represent 5 plus 5 plus 1. So that would represent 11. Then there was 3 dots, so that would represent 3. And we have 3 bars with a dot above. So 5 plus 5, 10, plus 5, 15 with a dot is 16, right? So these are the values of the individual numerals. But together they form a larger number. So let's see how we can come up with that number. But before that, let's discuss the positional values of each. Now, the bottommost digit has a place value of 1. So let's write the positional values here. All right. So positional values in the Mayan system. So the bottommost digit will have a positional value of 20 raised to the power 0. So they use base 20. So it would be 20 raised to the power 0, which would have a value 1. The digit above it would have a place value of 20 raised to the power 1. So that would be 20. So that looks consistent with the Babylonian system and the Hindu-Arabic system. However, from the digit above it, that means the third digit from the bottom, would have a place value system, which is 18 times 20 raised to the power 1. So from the third digit onwards, third digit from the bottom onwards, they multiply each base value, each 20 by 18. All right. So 18 times 20, and then the next value, the next higher value will have a positional value of 18 times 20 squared, followed by 18 times 20 cube, and so on. So 18 times 20 would be 3600 when we multiply 18 and 20. 360, I'm sorry. All right. It has a value of 360, but 18 times 20 squared would have a positional value of 7200, 7200. 7200, and 18 times 20 cube would have a positional value of 144, followed by 3 zeros, 144,000. And you can keep going. The next one will have, above. Again, we are moving vertically here. So the one above will be 18 times 20 to the 4th, and so on. All right. However, to convert from one to the other, we use to convert from the Mayan to the decimal. All right. We will use the process of multiplying each digit by its positional value. So the bottommost, all right, the bottommost place value is a 1. So we take this number 16 and multiply it by 1, or 20 to the power 0. So I'm going to write this as 16 multiplied by 1, which is 20 to the power 0, to get a value of 16. All right. The next one above is 3. So that will need to be multiplied by 20 raised to the power 1, 20. So let's write that. It's 3 times 20 raised to the power 1 for a value of 60. Right? And finally, for the third digit above, the place value is 360, correct? So it will be 11 multiplied by 18 times 20. Let's write it like that, in fact. It's going to be 11 multiplied by 18 times 20 to the power 1, which is 360. 11 times 360 would give us a value of 3960. All right, and once we have all those values calculated, just go and add them. Now we are working vertically. So 3,960, and let me just write it down in their proper places. So we do our addition correctly. 60, and then the bottom one was 16, correct? So 3960 plus 60 plus 16, when we add them together, we get a value of 6, 12, 13, 9 plus 1, 10, and 3 plus 1, 4, for a value of 4036. So this entire pattern of numerals represents the number 4036. All right, it represents 4036 in decimals. All right, in decimals. So that is how you go about converting from the Mayan system to the decimal system. All right, so you have to, the numerals will be provided to you on the test, so you don't have to memorize the numerals, but you will need to remember the positional values of each system, right? I'm now going to work through an example of converting a decimal value to its Mayan numeral equivalent, all right? So it's the same process that we used when converting to the Babylonian system, where we were performing division. We took the number we wanted to convert and divided it by the place value which is closest to it without going over. We are going to follow the same process, except that the place values we divide by are going to be different because we are going to use the positional values of the Mayan system here. All right, so the number we want to convert is 4025. So let's look at the different positional values. We have 1, then 20, then 360, and the one after that is the next higher value is 7200, but 7200 is greater than 4025, so we have to perform our division with 360. Remember that the divisor cannot be greater than the dividend, that the number that we are dividing. So we'll have to work with 360. So I'm going to divide 4025 by 360. So 1 times 360, we subtract 360 to get 442 as the remainder, bring down the 5. So again, 1 times 360 minus, so we have a remainder of 65. All right, so we got a quotient from the first division. We got a quotient of 11. I'm going to write that 11 below the positional value we divided 4025 by. All right, to continue with it, we take the remainder now and we will be dividing it by the next lower positional value. So 65 divided by, so it's going to be 65 divided by the next lower positional value is a 20. 20 is less than 65, right? So we'll divide it by 20. 20 times 3 is 60. Subtract, we have a remainder of 5. So we are done with this division. The quotient was 3. Again, I'm going to write the 3 below the positional value that I divided 65 with. All right. And now we have to do one more division with the remainder 5. All right. So 5. Let's do it 5. But the next lower positional value is a 1. So we'll divide 5 by 1. And the quotient will be 5. And the remainder is 0. So again, I'm going to take the quotient 5 and write it below the corresponding position of 1, positional value of 1. And now we are ready to express these different digits that we got from the division in the Mayan numerals. All right. So remember, the Mayan numeral flows vertically with the lowest place value at the bottom, and then as the place values increase, we move up the ladder. So the first one is a 5. So let's look at the numeral that represents 5. It's a horizontal bar. So I'm going to put a horizontal bar here, a horizontal bar to represent 5. The next one is a 3. So 3 is expressed as 3 dots, correct? So let's express that and just space it out because it's a separate digit. And then the next one is 11. So 11 will be expressed with 2 horizontal bars. Each horizontal bar represents the number 5. So 5 plus 5, 10 with a dot above. That's 11. All right. So this entire pattern of Roman numerals represents the number 4025 in decimals, or the Hindu Arabic form. All right. So this is how you will go about converting from decimal to the Mayan system. Okay. Just came back to correct myself. I think I misspoke and said that this pattern of numerals, I used the word Roman, but this is really a Mayan numeral system. So just wanted to correct that. And this system, or this entire pattern of Mayan numerals, represents 4025 as in the Hindu Arabic system.